Can Go really compete with Rust's safety in 2025? If you're building anything close to systems-level software in 2025, you've probably asked yourself, should I double down on Rust, or has Go caught up enough to be worth serious consideration? Today, we are cutting through the noise with a grounded comparison across 4 key pillars: memory safety and performance, concurrency models, tooling maturity, and real-world adoption trends. Whether you're maintaining critical infrastructure or designing scalable back-end services, this breakdown will save you hours of research. And at the end, you'll get a clear answer, not just which is better, but which fits which kind of developer and workload best. Rust's biggest selling point remains its memory safety without a garbage collector. That's still true in 2025. The borrow checker enforces ownership and lifetime rules at compile time, preventing whole classes of memory errors before your code ever runs. This yields zero cost abstractions, predictable performance, and no garbage collection overhead. That design makes Rust a standout for low latency systems, game engines, and embedded software, where determinism is essential. Go, meanwhile, uses a concurrent, mostly low pause garbage collector that continues to improve. The garbage collector is incremental and concurrent and aims for short, stop-the-world pauses. For most web and cloud workloads, those pauses are small enough to be negligible in practice. The trade-off is philosophical. Rust asks you to reason explicitly about ownership. Go hides that complexity behind the runtime. One prioritizes precision and compile time safety guarantees. The other prioritizes simplicity and speed of development. What about speed? Across major benchmark suites, Rust frequently outperforms Go in CPU-bound tasks and often uses less memory, while real-world differences depend on the workload and implementation details. In I/O-bound and highly concurrent services, Go often closes the gap thanks to its scheduler and runtime ergonomics. Result: edge and embedded teams often lean Rust, while cloud and backend teams often lean Go. Both can be fast. They just optimize for different constraints. Let's talk concurrency, one of the biggest divides between these languages. Go's Go routines are legendary. Lightweight threads multiplexed by the Go runtime. You can spin up thousands and communicate via channels with very little ceremony. That simplicity is what made Go so dominant in distributed systems. Under the hood, the runtime scheduler keeps things efficient and scalable with minimal mental overhead. Rust doesn't include a built-in scheduler. Instead, it offers async and await, and lets libraries like Tokyo or async std provide runtimes. This approach offers fine-grained control over tasks and resources, but it requires more upfront learning. Lifetimes, pinning, and ownership inside async contexts. If concurrency were music, Go is a jazz band, smooth and spontaneous. Rust is a symphony, precise, complex, and beautifully orchestrated when done right. Both sound great. One just takes more practice. In 2025, Go's concurrency remains the easiest to use at scale, while Rust's async excels when you need precise resource control and absolute performance. Now let's talk tooling and developer experience. Both ecosystems feel mature and polished. Rust's Cargo remains one of the best package managers in software development. Reproducible builds, smooth dependency resolution, and strong version management. Its compiler diagnostics are famously helpful, guiding developers through ownership and lifetime issues step by step. And with Rust Analyzer, editing and auto-completion in popular IDEs like VS Code feels modern and snappy. Go's tooling remains one of its greatest strengths. GoFMT enforces a single style for everyone, and the built-in race detector helps catch concurrency issues before they hit production. And of course, the addition of generics in Go 1.18 gave developers a new level of type safety and code reuse without making the language harder to read. Rust's tools help you write correct code, Go's tools help you write consistent code, and while Rust compile times have improved, Go's near-instant builds and single binary deployments are still a major edge for teams working at cloud scale. Now, the real-world picture. Rust has become a staple in systems programming, security, embedded work, and WebAssembly. The Linux kernel now accepts Rust components. Microsoft uses Rust in Windows to improve memory safety. AWS's Firecracker micro VM, the technology behind Lambda, is written in Rust. The Rust Foundation, backed by companies like Google, Microsoft, and Amazon, supports the ecosystem's long-term growth, and new frameworks like Bevy for game engines, U for WebAssembly, and Embassy for embedded async show how fast Rust's reach is expanding. Go, meanwhile, remains the beating heart of cloud-native infrastructure. Kubernetes, Docker, Prometheus, Terraform, and Grafana, all built in Go, define modern DevOps. Go powers the systems that run the internet. Companies like Uber and Cloudflare rely on it for high-performance back-end services, thanks to its simplicity, concurrency model, and stability. In practice, the two languages complement more than they compete. Rust dominates the systems and edge layer. Go dominates the service and cloud layer. And more companies are combining them, writing high-performance libraries in Rust and calling them from Go-based microservices. When it comes to developer experience, Go still wins for onboarding speed. A developer can be productive in Go within days. With Rust, the learning curve is steeper. Ownership, lifetimes, and borrowing take time to internalize. But once you get it, those compile time guarantees eliminate whole categories of bugs that plague other languages. In big organizations, this trade-off plays out predictably. Fast-moving product teams pick Go, platform and infrastructure teams pick Rust, and more both coexist beautifully in the same stack. Let's talk momentum. Rust's governance transitioned to the independent Rust Foundation, ensuring stability and long-term stewardship. Its community is active, open, and growing, with strong corporate support and transparent planning for each stable release. Meanwhile, Go's development under Google remains steady, but increasingly community-driven. Proposals go through open discussion, and the language evolves carefully to avoid breaking its famous simplicity. Both ecosystems now offer excellent language server integration, first-class IDE support, and stable multi-platform builds across Linux, macOS, and Windows. So, after all that, which one wins in 2025? If you're building high-performance software where every byte and microsecond matters, embedded systems, cryptography, operating system components, or even game engines, choose Rust. It's safer, leaner, and gives you complete control without the pitfalls of manual memory management. If your goal is developer velocity, deployment speed, and reliability at scale, web services, microservices, or cloud infrastructure, choose Go. Its concurrency model, fast compile times, and straightforward syntax make it unbeatable for distributed systems. Rust is the build-it-right language. Go is the get-it-running-fast language. And in 2025, both are thriving. Not as rivals, but as complementary tools shaping the next generation of software infrastructure. So, which one are you betting on? Rust or Go? Tell me in the comments. I'd love to hear your take. And don't forget to like and subscribe for more techie talk from the Techie Shop. If you like this video, watch this video here for more tech talk.